So yeah, after training our model, we have to check the performance of our model, right? So basically, there are a lot of performance metrics. Uh, so training the neural network is very important, and it's very important to choose loss function, important to choose optimization algorithm, important to use regularization. Any this kind of um, things are very important, but I think the evaluating our model is at least yeah, I mean important as choosing that like algorithms, because let's assume you have one model which actually performs very well, but you evaluate the model like performing bad. So that means you cannot judge your model whether it performs good or not. So choosing the best metric for performance to evaluate the performance is also important. Um, yeah. And also, there's no magic performance metric for all the tasks. So it depends on your task, and it depends on what you need after training your model. So, there are a lot of performance metrics. So let's start with true positive, true negative, false positive, and false negatives. I'm pretty sure that you already heard about these concepts. True positive, yeah, true positive, false positive, true negative, and false negative. So true positive is the predictions which were actually correct. So that are correctly identified samples are true positives. False positives are incorrectly identified samples. And correctly rejected means you predict as the negative and it was true. This is good. And false negative is incorrectly rejected. So you predict the sample as negative, but it was positive. So this one and this one, TP and TN is good, and false positive and false negatives are kind of you mispredicted the classes. So here, true and false terms are about ground truth data, and false and negative terms are about prediction. So most of performance metrics are in basically using this true positive, this four metrics. So yeah, let's take a look on accuracy. So in our training, we checked the accuracy and decided, yes, this model was better than the previous one, right? So what is accuracy indeed? So basically, in most cases, the accuracy is used in classification problems. That is number of correct predictions over number of all samples in test set. That means true positive plus true negative over all sum of all of them. That means the all number of samples. So yeah, let's take a look on this example. So let's assume you have your ground truth, that means your target output is 1, 0, 1, 1, 0, 1, 0, 1. The predictions are all zeros. So it seems like didn't learn anything, right? It's kind of predicting all zeros. So here, true positive is 0. Okay, and true negative is 3. That means our prediction predicted as negative. So it predicted all the samples as negative, but 3 of them was correct. That means true negative is 3. And false positive, that means our model didn't detect any positive examples. So the false positive is also 0. And our prediction detected all zeros, all negatives. And how many of them was not correct? So 4 of them was not correct. That means false negatives 4. So accuracy here is 43. Okay, so you had some target output, and your model just predict all zeros, and it still performs 33% in accuracy. And in this example, let's assume your model predict all ones, and this accuracy is 57. So basically, there's no difference between this model and this model, right? It's just predicting all zeros or all ones. But in terms of accuracy, it changes. So that means accuracy is not the best metric for evaluating your model. So here are some other examples. Let's take a look on this one. So our prediction predicted the sample as true, positive, this one, this one, this one, and only one of them was actually true. That means true positive is 1. Our model predicted the sample as negative, this, one, and only one of them was true. This is this one. True negative is 1. False positive is our model predicted the samples as positive, this, and this one, and 2 of them was false. This is false positive is 2, and false negative is 3. So this one, and this one, false negatives. In accuracy is 28. Okay, this model or this model, which is good, do you think? Okay, basically, this seems better than the previous one, but in terms of accuracy, it was lower than previous one. And here it was 86. Okay, so concluding, we can say that accuracy is not the best metric for evaluating our model. So maybe we need to check other metrics as well. Okay, I'm going to show you one image, and I want to ask which case is worse than the other one. So on the left top, yeah. So this is false negative, right? On the left top. And then right bottom, this is false positive. So both of them predicted wrong. And yeah, which one is worse than the other one? It depends on you, right? I think for males, this is worse. For females, this one, maybe. But yeah, in terms of accuracy, these two are the same, But we have to check the other metrics as well. So the other metrics are recall and precision. Recall is what proportion of actual positives was predicted correctly. So in target output, you have, for example, 5 positives, and how many of them you predicted as positives. And in precision means what proportion of positive predictions was actually correct. So this is the figure here to show the recall and precision. Yeah, so if your model produces no false negatives, has a recall of 1. For example, if your prediction is all 1 in binary classification, your recall would be 1, right? If your model produces no false positives, that means the precision is 1. That means your prediction is all zeros. Your precision would be very close to 1. Yeah, close to 1. That means all predictions were false predictions was indeed the true ones. So here's some examples using the same pairs of vectors. So here ground truth is the same, and prediction is all zeros. Here recall and precision is 0. In terms of accuracy, it was 43, right? In terms of recall and precision, it was both of them was 0. And here, if your model predicts all ones, and that means recall was 1, 1.0, precision was 0.57. And in this example, so our accuracy was 28. in the same pairs. But recall was 0.25, precision was 0.33, and in this precision was 1. That means our predictions predicted the samples as positive, this here, here, and here, and all of them was correct. If, for example, let's assume our prediction was something like that, predicted this one also as positive, then our recall and precision, both of them would be 1. And this metrics are mostly using for classification kind of tasks, and there are other metrics also for object detection. And the first one is intersection over union. This metric measures the localization performance of object detection. You have to define some threshold. For example, if our intersection over union value is over some threshold, then accept this detection as true and lower ones as false. And also it is used in NMS. NMS is non-maximum suppression to discard the several classes in the same location. So in object detection, for example, there may be some object, and our object detection can detect this bounding box with, for example, four classes. So it's impossible to be the 4 classes in the same location, right? So NMS is discarding the lower confidence score classes in the same location. So here, so this one is poor localization, right? And the score is 0.4, and this is a bit better. This is 0.73. And this is excellent. It's kind of overlapping the B box. Is 0.92. So let's try to understand understand the object detection metrics in face detection. Okay, let's recap. Let's redefine our recall and precision metrics in face detection. Okay. In the left top example, so our object detection detect all the faces, right? And there's no false positives. There's no false negatives, right? That means our recall and precision, both of them are 1. And this one here, right top. So our model predicted 3 of 5 faces, and that means missed 2 faces. So it should be, recall should be lower than the previous one, but precision is still in the highest level. And here, our model again detected the 3 faces, even if it detects the different faces, it's still the same, 0.6 recall. That means 3 over 5. And here we have the recall, we have detected 3 of 5 faces, and we have also 1 misdetection, which affects the precision. That is 0.75. Yeah, and I'm pretty sure that you all already heard about average precision and mean average precision object detection. So average precision is a kind of average of multiple precisions. What kind of multiple precisions? So let's first define our intersection over union threshold. Let's define it as 0.5, okay? And yeah, accept the object detections which has intersection over union score which is bigger than 0.5. Okay, this is fixed already. And rank your detections in terms of confidence scores. Like this was detected 0.9, so put it here in the first place. And this one's 0.7, 0.6, 0.3, 0.2. Okay, rank all your detections in terms of confidence score, and decide if it is correct or not. So this is true, right? True. Okay, this is true. This is false. This is true, and this is false. And then, yeah, here the precision is, so let's assume your confidence threshold was 0.89, something like this. And so here it was, that means you detected one of 5 faces. So recall is 0.2 and precision is 1. And let's assume your confidence threshold is 0.89, 69. Precision still 1, but recall is increased because you detect 2 faces from five of them. And yeah, you keep doing something like this and write all possible recalls here, 0.0, 0.1, like 11 entries here, and try to map the precision in that recall. For example, for 0.0 recall, if the recall was 0.0, precision would be 1 because it was already 1 in 0.2, and you should write all maximum precisions at every recall values, and then calculate the average precision. So average precision is the average of mean of precisions in each recall point. Okay, so here there was 5 times 1, 2 of 0.75, 4 of 0.6. So our object detection's average precision was 0.81. Okay. So this is the average precision, and the mean average. So since our problem is binary classification, kind of face or not, right? We have only 2 classes. Mean average.
And why this 0.10 precision 1? Because you set the threshold of 0.69. That's why 4 faces. Why is the precision 1?
Where? Which one?
Yeah, there's 5 faces.
It's all, this one? Okay. So the definition of average precision is the maximum precision value at each recall. So for 0.0 and 0.1, it should be 1 because it was already 1 in 0.2. It's okay. But here, so this is, and 0.3, it should also 0.1 because in 0.2 and 0.4 it was 1, and in between of these two it also would be 1. That's why we have 5 ones here, and in 0.5, so it is somewhere here. So yeah, it's kind of a bit complicated, but the maximum precision at each recall. So here the maximum precision is 0.75. That's why 0.75, 0.75, and the others are 0.6 for 0.6, 7, 8, 9. Okay. So our average precision is 0.81. Since our problem is binary, our average precision would be equal to mean average precision because mean average precision is average precision, mean of average precisions over all classes. Since we have only 1 class, face, we have only 1 object, face, our mean average precision would be equal to our average precision. So in COCO dataset and COCO results, you mostly see something like this, right? Mean average precision at 0.75 means mean average precision over all classes if you define your intersection over union threshold as 0.75. So this is the metric in object detection. Yeah, that's all about metrics.
I never understand what MLT really means. It's so deceiving. I mean, for this one, I would say it's only 60% correct.
Yeah, in terms of accuracy, right? Yes.
But,
Yeah. Yeah, it may be. Yeah, if you would have like several classes, not on the faces,
yeah, right.
in that case, this mean average precision would be much more meaningful.
Yeah, right.
Yeah, because there's only one class, accuracy may be more reliable.
How do you get this number?
Which one?
10 times?
This one?
Yeah, spherical and precision.
I got from this table. Maybe you can check the references. We are going to share the. So this guy, not this one. This guy, yeah, has pretty good explanation. Yeah. So, any questions? Can you use the microphone? I cannot hear.
There's more the slides and the slides afterwards to get so we can refer and to the slides and the references as well.
Yeah. Sure.
Will they be on the repository or?
Yeah. We are going to put on repo.
Thank you very much.
Okay, thank you for coming, for attending our workshop.